All right, section 2. Chapter 4, section 2. Math 1314. More on math. All right, this section deals with polynomial and rational functions. Remember, polynomial functions will use p of x. Here's some conditions about polynomial functions. Their domain is from negative infinity to positive infinity, meaning that since it goes from negative infinity to positive infinity, it's continuous. It's a continuous function. That means there are no breaks. There are no breaks in the graph itself. Rational functions are fraction functions. All right, so let's look at this. We're going to look at the graph, how to graph polynomial equations. Let's say I give you this polynomial. Negative 2x to the fourth plus 3x cubed. So to graph this thing, let's look at everything we can find from it. We could do the leading term test. The leading term test tells us, this is the leading term, it tells us the shape of the graph. So it tells us 2x to the fourth. It's a fourth order equation. Degree is 4, so both ends point the same direction. Since it's negative, we know it points down. And since it's 2, that means it's pretty skinny. B, let's look at the y-intercept. The y-intercept is any constant. Since there's no constant, that means the y-intercept is 0. That means it goes through the origin. We look for the x-intercepts. The x-intercepts are also called the zeros. That's when we set the polynomial equal to 0 and solve for x. When we graph these equations, these zeros have another name. We call those critical values. Because at that point, we know that part of the graph will be above the x-axis, part of it will be below the x-axis. And this tells us where they're going to change. We can find the multiplicities. We can find a few extra points. For the graph. All right, so let's look at this. We know the basic shape. So the first thing we got to do is we found the shape. We found that. So let's look at the zeros. 2x to the fourth plus 3x cubed equals 0. That means we have to factor this and solve it. So what do they have in common? Not the numbers. This one has 4x's, this one has 3x's. So I could take out 3x's. If I take out 3x's out of both of these terms, what do I have left? So 4 minus 3 is just 1. And I took away all the x's, so I have that. So I have a linear equation inside the parentheses, which is my goal. So now I take both of these equations, anything that has x, I set them equal to 0. Because this x in front tells us a lot. It tells us that x cubed to 0 means that x equals 0. Remember I said it goes to the origin? If y is 0, x has to be 0. Now this one, we subtract 3 from both sides. First, change the signs. So we have 2x equals 3 and divide by 2. Three over 2, which is the same thing as 1 and 1/2. So those are my x-intercepts. So I've got x-intercept at 0. I've got a y-intercept at 0. And I have another x-intercept at positive 1 and 1/2. Here's 1 and 2, so there's the second one. Now, so what else can we see here? Because in our factored form, this is our factored form. Let's look at the multiplicities. At this one, the multiplicity is 3. So my zeros and the multiplicities. My zeros at 0, its multiplicity is 3. And that 1 and 1/2, its multiplicity is 1. Remember what I said last lecture, that if our multiplicity is odd, then the graph crosses at that point. It crosses the graph at that point. And if it's even, it touches. It just bounces. So we know that we have the degree of our equation is 4, which means both ends is pointing down. So we know that from these end points, from these last dots, the graph goes down. All right. So let's look at what happens here. We know at 0 it crosses. And at 1 and 1.1/2 it crosses. And what happens between there, we don't know. That's why we have to plug in some points. That's why we have to plug in some points and see what happens. So, at 1, let's see what happens at 1. So it's -2, 1 to the 4th, plus 3, 1 to the 3rd. 1 to the 4th is 1. 1 to the 3rd is 1, so it's -2 plus 3 equals positive 1. So at 1, it equals 1. Let's look what happens at 1/2. F at 1/2. Two 1/2 to the 4th plus 3 1/2 to the 3rd. So it's negative 2. 1/2 to the 4th. So these both get to the power 4. So 1 times 1 times 1 times 1 is 1. 2 to the 4th. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. Now these get to the power 3. 1 to the power 3 is 1. 2 to the power 3 is 8. So remember, 1 to the 4th to the power 4 is the same thing as 1 to the 4th, 4th to the 4th. All right, so now we can, so 2 and the 16 cancel. So we have negative 1/8 plus 3/8 equals, since we have a common denominator, 3 minus 1 is 2. They cancel to get 1/4. So that equals 1/4. So our graph looks something like that. Remember, it's a 4th order. So we're going to have 3 vertices. At most 3 vertices. So we'll look something like this. Yeah, so that's the hardest part. And you definitely use calculators to do the calculations. And you can also check your graph with it too. All right, let's look at the next one. This is another example. P of x is equal to x to the 4th minus 7x third plus 12x squared plus 4x minus 16. For right now, I'm going to give you the factors of these. But next class, we're going to learn how to do it ourselves. So we have x plus 1, x minus 2, x minus 2, x minus 4. So that's the complete factor of that polynomial. The reason, okay, I gave it to you this way so we look at 2 things. Let's look at these 2 terms. Where does x to the 4th come from? X times x times x times x times the coefficient. If there's a coefficient there, if we can factor something out. So 1, 2, 3, there are 4 x's, that's that. That's where the first term comes from. The last term comes from the last term. So positive 1 times negative 2 times negative 2 times negative 4. There are 3 negatives, so the answer is negative. 1 times 2 is 2. 2 times 2 is 4. 4 times 4 is 16. So that's where the numbers come from. And the rest of the stuff in the middle, that's for next time. So we see that these 2 are the same. So we have x minus 2 squared, since there's 2 of them. So this is a 1, and that's a 1. It only occurs one time. So if we add the multiplicities, 1 plus 2 plus 1, we get the degree. So set these equal to 0. And then what we get, remember, we learned earlier, it's always the opposite of what's inside here. So x plus 1 becomes x equals negative 1. X minus 2, the answer is x equals 2. X minus 4 equals x equals 4. So those are our zeros. Is that negative 1, 2, and 4? Their multiplicities. Negative 1 has a multiplicity of 1. 2 has a multiplicity of 2. And 4 has a multiplicity of 1. All right. Again, that's going to help us. Since we know the degree is 4, the leading coefficient is positive 1. We know that the end behavior will look something like that. They both go the same direction. So the negative 16, we know that our graph crosses the y-axis at negative 16. This little sign here means that instead of going all the way down, I went ahead and skipped all those numbers. So 1, 2, 3, not all the numbers, negative 15, negative 16. So negative 1, negative 2, negative 3. So our zeros are at negative 1. Our zeros at 2 and at 4. We know that the end behavior out of the little end parts, our graph looks like this, because they both end the same direction. At negative 1, the multiplicity is 1, so the graph crosses. At 2, it just bounces. And at 4, multiplicity is 1, so it crosses. So we'll have a graph that looks something like this. Right, so that's what the graph is going to look like. It's a rough graph of it. Okay, that's where you'd have to create a table and plug in some points and see where they lay. All right. All right. The next topic in this section, in section 2, is called the intermediate value theorem. The IVT. There's a lot of writing. The intermediate value theorem says this. If I have a polynomial function and at 2 points A and B their values are opposite signs. So if let's say this is P of A, and then let's say this one's P of B. This is point B and this is point A. Remember, polynomial functions have to be continuous, so there has to be a line that connects these 2 points. It can look like anything. So, since in this example, the value of P of A is above 0, and the value of P of B is below 0. This one's above the x-axis, this one's below the x-axis. Then there must exist another value C where C is between, so here's A, here's B. There has to be a value C somewhere between there that the value of the function at that point is 0. The intermediate values theorem says this. If I have 2 points on opposite sides of the x-axis, then there has to be a point between those 2 points where it equals 0. Like right here. That is my C point. I mean, there could be more, but there's at least 1 point where we can calculate it. So that's the intermediate value theorem. The graph could look like this also. Here's A, here's B, the graph could look like this. There could be at least, it says at least 1 point. So this is 1 point, 2 point, 3 point. We can have 4, again, depending on the graph and what A and B you pick, there could be a number of x-intercepts. And that's what the C value represents, the x-intercepts. All right, so that's what the intermediate value theorem states. Okay, let's look at a couple of examples, calculation-wise. That's graphical. Let's look at numbers. Example. Polynomial. X cubed plus x squared minus 6x. This first one, let's look at A being the point -4 and B equals the point -2. Let's determine if there's a value C between there. Remember, so -4 is less than -2. Let's determine if there's a value C between there. So the first one, just plug it in there, -4. So we have -4 cubed plus -4 squared minus 6 times -4. Okay, negative 4 cubed. Since there's 3 of them, the answer is going to be negative. 4 times 4 is 16, times 4 is 64. This next one, negative 4 squared. Negative times negative is positive, so the next one's positive. 4 squared is 16. Negative times negative is positive. 6 times 4 is 24. Negative 64. Let's put these together first. 16 plus 24 is 40. Since 64 is bigger, it's negative. 64 minus 40 is 24. So what that says, what that tells us, the value at negative 4 is 24. So it's the point negative 4, negative 24. And let's try with negative 2. Negative 2 cubed plus negative 2 squared minus 6 times negative 2. So again, negative cubed is negative. 2 cubed is 2 times 2 is 4, times 2 is 8, so it's negative 8. Negative squared is positive, so it's positive. 2 squared is 4. Negative and negative is a positive. 6 times 2 is 12. So combine like terms. 4 plus 12 is 16. 16 minus 8 is 8. In the first one, we had negative 2 cubed. That's negative 2 times negative 2 times negative 2. Since there's 3 negatives, it's going to stay negative. 2 times 2 is 4, times 2 is 8. You're welcome. So we see our 2 points. Negative 4, negative 24, negative 2, positive. Since the values have different signs, then there is at least 1 point, call it C, where P of C at that value where it equals 0. That's all the intermediate value tells us. So there's at least one. Well, let's just want to see if we can figure it out. Let's look at this. We're saying there's at least 1 point. So we have x cubed plus x squared minus 6x. Says that equals 0. All of these have one thing in common. They all have an x in common. So I could take out 1x. So if I take out 1x, this is x squared. Take out 1x, I only have 1x left. And it's minus 6. Let's see about factoring this one. X squared comes from x times x. The second sign is a minus, so it tells us the signs are opposite. One's positive, one's negative. And the bigger number gets a positive. So what times what is 6? When you subtract them, you get 1. 3 and 2. So now we set all of these equations equal to 0. So here's our first answer. There's our second x-intercept. And there's our third. Each of these are my C points. Those are the points where it crosses the x-axis. And this tells us that I'm going to have at least one. I have 3 of them. Okay, so that's what that tells us. That means once, using the intermediate value theorem, once we see that the 2 points that we pick, this is A, this is P of A, this is B, and this is P of B. Our 2 values give us different signed answers. If once that happens, then we know we will have factors, or real answers. Let's look at another example. One-third x to the 4th minus x cubed. I'm saying that A equals 1 and B equals 2. Remember, I'm looking for some value C if this is possible. So A is 1, B is 2. So I'm looking to see if there's a value C between those two. So at A, first one's at A, so put 1 inside there. 1 to the 4th minus that. So 1 to the 4th is 1. 1 times 1/3 is 1/3. 1 to the 3rd is 1. 1 is the same thing as 3 over 3. Just look at the top number since we have a common denominator. 1 minus 3 equals negative 2 over 3. Okay, I'm sorry. Yeah, these are just given. This whole thing is given. I gave you the function. What's that? No. So I gave you the polynomial. I'm going to say, okay, at these 2 points, let's see what the values are. Because if when we do our graph, for example, when x is 1, that's what we did here. When x is 1, we got negative 2/3, which is down here. Now we're going to see what happens at 2. We need 2 separate points. And then if this value is below the x-axis, then there's no x-intercepts. We don't have to try to factor it between there. But if it's above the x-axis, there are different signs, so the line has to cross somewhere. So that's what we're looking for. So this is given. So P at 2 equals 1/3 2 to the 4th minus 2/3. So 2 to the fourth. 2 times 2 is 4, times 2 is 8, times 2 is 16. 2 to the third. 2 times 2 is 4, 2 times 4 is 8. So this is 16 over 3 minus 8 over 1. You get a common denominator. Multiply top and bottom by 3. 16 over 3, 24 over 3. 16 minus 24 is negative 8 over 3. So we look at these two answers. Since they're both negative, there is no value C between 1 and 2 where the polynomial equals 0. So there are no x-intercepts between 1 and 2. That's all it tells us.